Okay, so thank you very much for attending my presentation today. I also have a co-speaker, Hans Edert from SAS. He will introduce himself later on. So thank you very much for being here. I'm IT architect. My name is Marc Wewers. I'm from MunichRE. And today I would like to say something about our journey of our big data analytics platform and our central data lake. That's our agenda. So first, a little talk about our data analytics framework. Then later on, I will share the agenda point about technology with Hans. And in the end, I will say something about the data lake and lessons learned. Yes, just very rough advertising from my side, because maybe if you're not familiar with insurance or not part of the insurance industry, you never heard about MunichRE. So where are we? We are the world's leading reinsurance company. So that means we are insuring insurance companies. So that's maybe why you have no contact with us. But we also have a company for primary insurance. Maybe you know them. It's ERGO. So that are our two main pillars. But from my side, I'm here for the MunichRE group. So that means I'm for the reinsurance group here. And then in the end, we also have MEAC. That's our asset management company. So that's roughly our company. And we have a long history. So we have already been founded in 1880. And yeah, we deal with all these big catastrophes, for example. So there was a big earthquake in San Francisco in 1906, and that's also where we had our brand was really born, and because we were able to manage the big losses that have happened during that earthquake very fast, and also during the time, for example, in 2011. There were a lot of catastrophes, and even in that one single year, we had 380 billion US dollar of claims. So really dealing with these big natural catastrophes and other things. Also, we're why is big data of interest for us, or why is it also changing our business model? Because we already deal with a lot of data. When you think about earthquakes and natural catastrophes, there's a lot of data, and a lot of houses may get collapse and so on. But we're already doing maybe big data since years. But now with these new technologies came into place, even for us, it made sense. Okay, there's new technology, and this can even solve things that we couldn't solve before, or even we can now insure things that couldn't have been insured before because you didn't have the right data or maybe the right processing capacity to handle these insurance topics. So, for example, wind energy. If you invest in such a big wind park, you are investing in a couple of 30, 40 years of investment, and this really is then important that you say, okay, I'm investing in this park, and I have this revenue out of this park, and I'm calculating with the kind of energy that you get each month out of the park. But what if the park, there's a technical breakdowns or other things? You need someone that helps you in taking the risk, and that's us. Then we can take the risk that, for example, if the park has a failure, we can insure this and take the risk for you. And this is really, for us, also new cases, and for us, for example, is a big data use case for us. Other things are automated underwriting, that if we sign new contracts, we use new technologies to automate the underwriting. Or do early loss detection, so we are crawling the web to see what's happening out there. Is there a fire somewhere, a big warehouse burning? And then instead of getting this message after a couple of months from our first primary insurance, we can directly see, okay, has something happened, and we can directly do action on these events. Or even do visual loss adjustments using drones and see, okay, there has something happened. We can use a drone with picture detection and see, okay, what really has happened, because we also don't want to risk any personal life. We can then use drones and see where are the damages on that house or that building or that whatever warehouse. So these are really new topics for us because, as I said, the things were not insurable before, and now with new technology they are. What big data analytics in our case is built of, for sure, and what makes our team such important is we don't only have unique methods for sure, regression models and all these things to calculate all these risks and things. That's common. Maybe machine learning is a little bit new coming to place, and text mining is also getting more and more important. But these are methods that are there. Technology for sure is also there. The hardware you can buy and you bring into place in your data center or in the cloud. Then it turns a little bit to be, there are new influences, right? You have the internal data since years, but you also are starting to take external data and combine it with your internal data to get new insights. And also in former times, you have a lot of information maybe in your data warehouses, very structured, but there is a lot of information hidden in the unstructured data, and that's really where you also need to dig into and look what's in there, what can make sense to use for further use cases. But the most important thing is, I would say, the people, and that's also what we established. We have a data analytics team, and it's a virtual team, and it's from both sides. Let's say we have business in the team and we have IT in the team. So I'm from the IT side, but it's very important that you have both in the team, work together, have small teams working on use cases, but also for setting up the platform as we did. It's very important to have everyone in the team, and the data analysts, the data scientists, but also the IT architects and all the other IT guys you need. So this is one very crucial thing, and this really helped us to bring this platform very fast into life and in a real production mode. This was just some, let's say, overview about what is big data for us and where is it coming from. Now our journey begins. First, for a journey, you have to say, okay, what are our design principles, right? You cannot start with anything. You just have to concentrate on something. So for us, our big data analytics platform, although we already have SAP HANA, for example, in place since a couple of years, there's our structured data, our transactional data is already there. But what was new for us are the two other pillars. So, for example, SAS for our analytics, and MunichRE for our big data use cases. And so we had to then, in the last 2 years, set up these two new technology stacks, SAS and MunichRE, to cover also the unstructured part in the Hadoop world and the analytics part with SAS. And that's why it's also in the middle here. That's the self-service part. It's in the middle, in the center. Self-service. Self-service is the key factor of our platform. Without self-service, it wouldn't work, and that's also why we have in our house a lot of interest in our platform. The users really like it because they can do everything on their own. They don't need big processes and us in doing IT tickets or whatever, and a change request here and a change request there, until they can even see their first report. They can do everything on their own, from loading data into the platform, analyzing everything, and do whatever they want to do some regression models on it or whatever. So this is really, the self-service is one crucial part. So what we think of making this platform also popular in our team, in our organization. Then the other thing is, maybe it's you heard it also maybe during this conference. It's this new term I heard also. It's now called Data Lake 3.0. Don't ask me why 3.0, but it's the multi-tenancy, right? You have one big cluster with a lot of different workload and a lot of different use cases on one platform, sharing resources, but also be able to kind of say, okay, here's a use case, and you're just able to see this data, and here you have your own folder, your own structure where you can do your project in, and you are not disturbing the other use cases. So this is the multi-tenancy is also very important for our platform to make this happen. We don't want to install a lot of Hadoop clusters. We just have one big cluster with all the use cases side by side. For sure, this comes with security. Without security, this wouldn't be possible. And then what then comes after is also the one central data lake. We don't want to have different data lakes for HR, for finance, for other purposes. It's one central data lake. You already have all the use cases with multi-tenancy on one big cluster, and then you can start sharing between those use cases your data in one common central place, and make out of use case A, combine it with use case B, and then some use case C can be done and realized. This would be maybe not that easy if you have different clusters. It would be possible, but for us, we thought this one central data lake sharing all the resources and data is then a perfect place also for having this one data lake. Yes, all these, Hadoop and so on, you can imagine this cannot be done manual anymore, so also automation is very, very important. Without automation, handling all the cluster, the updates and so on, this is not possible. Also, this also feeds into the self-service thing that users can automatically do steps without having to involve IT, for example, and this also means you have to automate a lot in the background. DevOps, because we're a really technical session here, right? So I guess everyone knows that DevOps, you build it and you run it. So that's also what we think and what we are doing. We have small little teams. We have already mentioned, we have a business in team, and we also have all the IT guys in the team. And this means we can really build something and we can run it in the same team. And this also makes it possible that we can realize use case very fast. All of this comes then with continuous integration, continuous improvement, continuous integration also, but here I have continuous improvement. This means, we cannot longer wait for, let's say, half a year and then we upgrade something, we bring a new tool in production. Now it has to have very, very fast turn cycles, and here, in our case, every 2 weeks we bring new tools and features into production. Last but not least, on-premise and cloud, for sure, they are very important. On-premise, we are storing our very, very sensitive data. It's something where we don't want to give maybe into the cloud. And we also have all our transactional systems in on-premise where we also have to include this. So on-premise is for sure, it's there, it will stay there, and then make use of the cloud for burst out scenarios or so on. So if we get some earthquake data, it's a lot of data, a lot of gigabytes of data, and then you have to number crunch it, and that's the cloud for, right? You just ramp up your cluster, have a couple of nodes, number crunch, and then throw them away. And this makes perfect sense for the cloud. So these are our design principles and guiding principles that we are using to build up our platform. Then a very, very high-level view on what the platform looks like. It's separated into two different environments. the one environment we call BI Lab. You can see that's a kind of playground for us. We install the latest software, the latest versions of anything, try the software out, make new use cases and think, okay, what do we need for these use cases? Is there anything special we need to install, but we don't have it yet in the production? So that's really our playground. Less SLAs than on the other side, on the production side. Production side is really something that has been proven, and we really keep this in a stable mode, and it's really reliable, right? But stable, I said, it's still 2 weeks life cycle, so every 2 weeks we can still go into production and change things there. You can again see the 3 main pillars that are we are building our platform, as I said before, SAP HANA, Hortonworks, and SAS. And then for sure we have our data lake, the one central data lake that all these platforms can hook into and get access to. But in the end, this data lake platform is part of the production side, and we're just able to also from the BI Lab access the data. But the data is just once there, and the one central data lake, as I said, it's on the production side. How did we get there? So we started end of 2014, and then thinking about, oh yeah, what should we do? What can we do? And we set up our first Hadoop cluster beginning of 2015, and in Q2 we decided, okay, now we had our first installation, but what can we do? So we thought about our design principles, and we had to say, okay, we want to have this multi-tenancy. So what comes with multi-tenancy? You need to have authentication, security, so LDAP and Kerberos topics we designed during that phase, and also worked already on automation, because we already saw at that stage we need automation. Then we built up a second Hadoop cluster in the BI Lab, making use of this new security features and with the automation. In the end, we were able to set up new clusters in our BI Lab, one large cluster, but also for different IT purposes and testing purposes, just with this automation. Set up a cluster and within a couple of hours, do your tests, and maybe throw this cluster away. Then in Q4, kind of, we also then thought about, now we have this big data environment where we can store all these unstructured data, but we also have these all these self-service users. They want to make analytics out of it. So for us, then we decided, okay, SAS could be a big help for us. It's a good tool for also end users, has a user-friendly interface, and we can make all our business users also, not everyone can write SQL statements and so on. We have our data scientists for this, but also we want to make use, so the whole company should make use of this environment. So that's why we also then thought SAS can help us here. And in the end of then 2015, we had a couple of good use cases and saw that this combination helps us. And then our CDO approached our team and said, okay, now we've seen this is a good fit, and now let's stop playing. I need this in production. I want to have it now, make it possible. And that's then when he approached us, said, start the platform in production. Before we were just talking about our BI Lab, right, the left side of the former picture. And now we started then to set up the production environment. And our first release was then really just 2 months later, after our CDO approached us, and we said, okay, because he said as fast as possible, we said, okay, as fast as possible, you somehow have to limit the scope. So we said, okay, that could be a good approach, saying, okay, we set up the production cluster, but just with a limited scope. So just a couple of SAS tools and a couple of Hadoop tools out of the HTTP stack. This was possible, but already you can see a Ranger with LDAP, so the security and everything was in place for sure for production to already have this multi-tenancy. 2 months or 1.5 months later already, we released the second release. We rolled out even more SAS tools and more Hadoop tools on the stack, on the production environment. And then there was, let's say, a bigger gap between release 2 and 3, but it really made a lot of sense because just until release 3, we just had one environment. It was just the production environment. So for release 1 and 2, it's maybe not the common approach that you would think about, but we just had the production environment. But we said, okay, for IT purposes, we need a kind of sandbox integration system to say, okay, we upgrade and we have to patch this, the environment, and that's why we need the sandbox and integration system. And then with release 3, we had everything in place, also from IT side. Business could already start work, right, from beginning of February on. They could already work, they had their tools, but just the IT side was then also ready to start with the continuous improvement with a 2 weeks release cycle. From release 3 on, we can do continuous improvement and roll out even more tools and frameworks and technology in a 2 weeks life cycle. End of last year then, our data lake went live, so we had to install different additional tools like Apache Atlas and so on to then make also the data lake possible. We'll come later back to the data lake topic, so this I will not go into detail now for the data lake. Yeah, and now I would like to hand over to my co-speaker Hans, and he will also give you now even more details about our environment and how we've set up this environment.
Okay. Thanks a lot. Actually, I'm not Hans, I'm Elvis. I've returned for a short medley. Yeah. Right. My name is Hans Edert. I'm working as a solution architect in the local office of SAS in Germany. In case you haven't heard about SAS yet, some facts, some information. In the interest of time, just let me say one sentence. For the past 40 years, we have specialized in developing software, especially for analytics, for advanced analytics, also for BI and data management. And the platform has changed in the last years dramatically to make it fit, to make it available for running our stuff in Hadoop, because that has become ich bräuchte dieses Dings da. Danke. That has become a major platform also for our customers. That picture should look a bit familiar to you. This is just a high-level view of trying to answer the questions, what can you do with SAS on a Hadoop cluster? So the box in the middle, it's your HTTP stack, Hortonworks stack. Basically, nothing has changed. It's the regular stack. We have not taken away anything. We've just added stuff to it. To the bottom, you see the data sources that feed data into the Hadoop cluster. And I used blue overlay boxes to list some of the tasks that you can use if you want to run SAS jobs, SAS analytics on a Hadoop cluster. For example, bottom to top, we have technology to run analytics inside streaming data, to make analytical decisions even before the data hits the cluster. Then there's several ways to transform your data once it's inside the cluster. It could be plain SQL. You could use our own scripting language, which also runs on the data nodes directly. Then there's a large set of data quality rules that allow you to cleanse your data, to profile your data. Your Hadoop data. And then finally, there's a large portfolio all around the analytical pieces. Most importantly, we have our own in-memory analytics engine. That's something that end users, statisticians, data scientists, business analysts can use to interactively explore data that comes from the Hadoop cluster. And that engine is backed by a framework that allows you to train models, to evaluate models, run models in batch. That's the score overlay here. And then also retrain models as they become worse over time. That's a bit more technical. This explains the access patterns. How do you submit stuff to Hadoop from SAS. SAS is on the left-hand side, and SAS is a traditional multi-tiered architecture. So usually you're working with a client. It's a full client, it's a web-based client, it's a programming interface. We also provide a scripting interface, of course. And then you submit jobs to the cluster, and actually the workload is done on the right half of that picture, on the Hadoop piece. Yeah? Usually you don't run the SAS jobs on the left-hand side if the data comes from Hadoop, or if it's Hadoop data. And that could be simply, let's say, you submit some SQL queries to Hive. You can run HDFS commands. You could even push SAS code over to the Hadoop side, for example, for analytical models, prediction models, for example. And finally, I also already mentioned that there's this in-memory engine which can be used to interactively explore the data on the Hadoop side. And as you already can see, some of the blue boxes are on the right-hand side, and that means that from an administrator's point of view, we're adding something to the cluster. You have to deploy, or you can deploy, two SAS components on the Hadoop cluster. So if the green boxes are a regular Hadoop installation, edge nodes, management nodes, data nodes, and you run all the Hadoop jobs, the Hadoop workload that you are familiar with, then an Hadoop administrator would see SAS as two additional services on the same machine. One for batch, one for self-service, interaction. SAS EP, embedded process, is the technology for running SAS in batch on the cluster. And the in-memory engine, we call it Laser. That's the piece that will, that's a distributed technology. That's the piece that will allow you to run analytics on Hadoop data. And as you can see here, they're deployed in a different mode. EP is deployed on all the Hadoop data nodes, while we chose to implement the in-memory engine only on a few of them. That was a deliberate decision. You could change that, of course. And if you see that type of mix and match, then of course, one thing that is very important is that you have a proper resource management in place, because those workloads tend to cannibalize each other. And so we are going with Yarn. So we have set up Yarn queues, and that prevents those workloads to be rude to each other. We are nearly through. One final twist. You remember the picture that Marc showed? That would be the big box on the top here. That's the production cluster. And since this is a large installation, an enterprise-grade installation, there's, of course, you have the stages that you would expect, integration and also a sandbox. That's IT stuff. That's end-user accessible. But what we did is we actually deployed two SAS environments on a single Hadoop box, on a single Hadoop cluster, and we chose to separate what we call the scheduled analytics. This is the batch approach. This is the production, and we chose to separate that piece from the self-service analytics. This is the area where the end users hit the system, where they interactively in self-service mode load data, explore data, and so on. And one advantage of doing that is that we can easily grow and shrink those environments as they are needed. So typically, this environment might be larger than the batch environment because you have to ensure response times, but we can decide what size it should be on an on-demand base, and we can change that anytime, basically. Okay, thanks a lot. That's from my side. I'm handing back to Marc.
Okay. Thanks, Hans. And just to add this is also, again, feeds back to our design principles, having just one infrastructure, one central data lake, and because it's just one Hadoop installation with different workloads, and with this architecture we're able to the Hadoop cluster can independently be scaled from the SAS workload and vice versa. So this was very important to us to be very flexible but have also a lot of different workloads, because SAS is not just our only workload. We also have Spark, we have Hive, we have all these other technologies on this one cluster, and they should be scalable independently on just one platform. Now we have the data lake topic. Here it's just our nice comic about what we see from our data lake, how we describe our data lake. The most important thing is right in the middle. It's the catalog, right? I think we heard a lot about this also during the last 2 days here on the summit. You need to find out what's inside of my lake, where is it in the lake, who can access the data, where is it coming from, where is it going to, and so on. So without having this catalog, I think all of us would agree it wouldn't be possible to manage a data lake properly. So this really is then the catalog. Here we're using Apache Atlas, and then also we added other user front end. We're using Elation on top as for our end users, because it has also some nice capabilities about they can chat with each other, they can rank and rate different statements they have done on the data lake, and so on. The other thing is then for sure I also mentioned that the data lake, not only our internal sources fed into the lake, we also have a lot of external sources that will be a part of our data lake or are already part of our data lake. And then the thing that's also important is we have a kind of, you can see it in the lower right corner, kind of data quality established, saying, okay, you have your gold, silver, bronze data, where you can say, this is really something, bronze data, that's raw data, that's something for our data scientists. They want to play with the raw data. But for example, the managers who just want to see dashboards or clients, they should just see the gold data, right? The cleansed data that's available in the data lake. Yeah, for sure, you also need some restricted areas in the data lake because of some legal requirements. Sometimes not everyone should see everything. You also, although it's a big data lake and you want to start sharing data between everyone, right? There shouldn't be any information silos anymore in your organization. There are some legal requirements sometimes to have a little restricted area and say, okay, here's really, really high sensitive data that shouldn't be seen by everyone. Yeah, so in the end, this is our data lake. As I said, it's on a production environment, making use of the Hadoop technology, and yeah. In the end, I would give you kind of wrap up of our lessons learned. I thought this makes sense because of we thought it's a journey. So what have we learned from our implementation the last 2 and a couple of months, 2 years and a couple of months, I mean, sorry. For us, it was a big help to have this lab environment. We call it BI Lab, where we set up new things, try out tools before we bring them into production. And here we can also, if you have a use case, you don't want to make someone wait half a year until it's somewhere available. They want to start immediately, maybe 2 days later, and this we can realize with our lab environment without having too strict SLAs. So in the end, we have currently no SLAs in the BI Lab. Enable self-service, as I mentioned before, it's very, very important for all our business users. They want to get fast into, they want to upload on their own pace data, they want to use and number crunch and do all the analytics on top without anyone else. If they want to go on their own pace, and that's what they really like. Agile IT project management, as I said, continuous improvement, DevOps teams. This really helped us, and then to bring up this platform and still keep it in a good shape and listen to the users and we're kind of a Scrum methodology, right, to build up the platform and keep it stable and also improve it day by day. Automatization, I think I don't have to add any more to that. You have to have it, otherwise it's very hard to maintain. Security, yeah, a lot of tools they maybe are struggling with Kerberos and all this LDAP and so on, but it's definitely a must-have, and without security, it's not possible. And last but not least, yeah, Yarn queue management. If you have everything on one big cluster, don't underestimate the queue management. It's really important to have the different workloads and manage this workload, and you kind of have to start monitoring Yarn queues and maybe change them once a while, and to make all this happen on one big cluster in one data lake. So this would be our presentation. Thank you very much. Now we have how many? 5 more minutes for some questions, if you like. There's a question. I can see.
How did you exactly integrate SAP HANA into the data lake?
That's a good question. SAP HANA, we currently we are replicating the data from our SAP systems, from our data warehouse and our transactional systems into the data lake. So that's our current. We are thinking about virtual access to our data lake, but the first step was the replication. Yeah.
What does your disaster recovery process look like? Is it just a mirror image of that cluster in another data center, or?
No, we don't have. We have just everything in one data center, and currently, and we're building up the cloud and having there some also disaster recovery in place. Then, but currently it's just one data center.
So, are you planning to push data to the cloud as part of the disaster recovery process?
That's what we are thinking about in the future. Yes, currently we have it in one, doing disaster recovery in one place, but maybe in the future other places. End of 2014, yeah, we had our first use case. Could you rephrase?
Would you have considered public cloud in 2017 if you were starting now for this type of deployments?
We already started it, but we haven't finished our journey into the cloud yet. So we already started. The question was about the cloud. We started already last year already our first cloud POCs and journeys, but we're still. Security is not that easy in the cloud, so that's still a couple of topics which we have to manage.
What are the implications from your point of view, considering your described environment here, coming from the GDPR? How would the changes look like? I mean, you're planning them or already testing them?
GDPR, yes, it's. That's all about the security, right? You have to have the security in place, and also maybe in the future we are now want to make use of tech-based security and all this stuff to really see where is sensitive data, who should be able to see this and the data, and who not. I talked about these restricted areas, so we already have them in place, but we want to go further and make use of the.
Some kind of reporting and intrusion detection and prevention components. Maybe they will also come.
They will also come, yeah, for sure.
Do you archive some part, and what percentage approximately do you encrypt it? Last question.
I'm not sure if I can go into the details now. Sorry.
Do you have a second infrastructure for classic reporting, is the classic data warehousing?
As I said, yes, we have SAP HANA for, let's say, classical data warehousing.
So it's a separate architecture beside this one, right?
This one, which we showed here, it's the Hortonworks and SAS on one big environment, but this HANA is standing next to it, yes. But let's say, HANA is not on the same hardware, it's a separate hardware, but next to our data lake.
What are your plans for the future? Is it going to be a united architecture? Or?
It was kind of related to the question that was over there. Yeah, HANA should become even more integrated into our data lake. Currently, we are using it with some. We copy over the data, and in the future, it should be more virtual access, having also all the HANA resources available in the catalog, see what's there in our reports already, in our structured data, and make it more virtual accessible.
Okay, so you still have the data replicated?
Yes. Okay. Then? Tools we score data?
That's a question for me? Sorry. Yeah. Yes, indeed. There's a couple of tools in the SAS portfolio that are able to develop scoring models, prediction models, for example. And then, of course, the model can be run and executed on the data in Hadoop. Was that the question? I'm sorry.
Maybe you can just come over now, and we can. Yeah.
To avoid copying your data from HANA into your data lake, there's a new product called HANA
Vora, yes, I know about it. Yeah, yeah, we had already a couple of POCs with Vora. Yeah, so we know about this technology. Yes. that's the one where we think about virtualization and about the HANA and Hadoop. Yes. Okay.
Which was the name of the tool which the end users are using to browse the catalog?
Elation. Yeah. That's the UI on top of Atlas for us, at least for us. Okay. So, thank you very much.